Hello everyone, welcome to Probability and Statistics. In my last video we figured out how to get the joint PDF from a given range that was introduced at the top of the problem, from 0 to x plus 3. We drew a picture to figure out what that area was to find the distribution. Now we're going to find out what a specific probability is. And what you do when you first see a probability with relation to a continuous random variable is just kind of create what the range is. So this is going to be x greater than 0 but less than 1, and then x less than y less than 2. Okay, so we have the range of our integrals now, basically, and the reason it's x less than y greater than 2 is, again, the reason we drew this picture in the last video. You can kind of see where the range is. So we're going to go ahead and add on to this video. So if it's x from 0 to 1, you go ahead and say, okay, well 1's right there. So we've got the range of x is from 0 to 1, but then the range of y is from x to y2, basically, right here. So what we're looking for now is this area. So we need to integrate to find the area of this area in order to figure out what the probability is with relation to the rest of it. So what you do is you take our joint PDF and you basically integrate it. So we've got 1 over 24. I'm just going to go ahead and take it to the 24 on the outside already. And then you've got the integral with respect to x, 0 to 1, and then x to 2 of x plus y dy dx. That's how you can set up the integral. It's pretty easy. I mean, you go ahead and go from the y right here, and then you go ahead and do x, and you get the values that you need. These continuous random variables can get kind of complicated in finding these areas if for some reason you have, I don't know, an area with a funky geometry that goes like straight but then goes curvy up here and then back down or something like that. That's when you have to split up into even more integrals than just a double integral. Okay, so if you go ahead and do this, then I'm just going to go ahead and do the inside. You're going to go xy plus y squared over 2 x2, solving that out, you end up with 1 over 24, integral from 0 to 1 of 2x plus 2. I know I'm not showing a lot of detail on this, but the integration you should be able to do, which then go dx, which is then equal to, well, this part goes to x squared plus x squared over 2. So then this goes to 1 over 24, integral from 0 to 1 of negative 3x squared over 2 plus 2x plus 2 dx. So then taking the integral of that, you get negative x cubed over 2 plus x squared plus 2x. The range from 0 to 1, and you end up with 1 over 24 times negative 1/2 plus 1 plus 2 minus 0, the 2 halves of the integrals, which equals 2.5 all over 24, which is equal to 0.104. And that is your probability of getting a point within this area. So it's pretty simple. You just go ahead and take the integral of the joint probability density function that you found in the very first part of the problem. And then you can do this for any kind of a range. So if you for some reason only are given like one variable, like I'll go ahead and show this. So like the probability of x being greater than 1 but less than 2, well, you're not given any value of y here. So you assume that you take all y's. So if you were to set up this integral, you go ahead and go 1 over 24, taking the constant outside the integral. The range of x, 1 to 2, and then the integral of y is the range of the original y, which is from x to x plus 2 of x plus y dy dx. And that's how you would do a single variable probability. You just go ahead and take all the entire range of the variable that's not included in this right here. And if you want to draw a picture of this one right here, using the picture we had earlier, I'm going to go ahead and do this. This is 2. This is y equal x. Got 1 and 2 right here. 1 and 2, the range of x. Fill that in. And this is the area you're trying to find from the original area that was restricted to 3. 3 goes clear up to there. This was the total area. Now you're trying to find the probability of finding a point in this area. So that's how you set that up, is just finding that integral. So not too hard. You just have to know your calculus decently well.